So the first thing that we need to do is look and write down our given data. So we know that mass is equal to 9 kilograms, height is 5 meters, and x is 19 meters. So the first question is, what is the speed of the box just before it reaches point A? So we need to find the speed. How are we going to do that? Well, we know that gravitational potential energy is equal to kinetic energy. So we can first calculate gravitational potential energy in order to get kinetic energy, and then we can derive V from the formula of kinetic energy, which is, I'm going to write it here. Okay, and the formula for gravitational potential energy is mass times G times H. So let's calculate GPE. GPE is 441.45 joules. I'm actually going to move to this side. Joules, which means that our kinetic energy is equal to 441.45 joules. Okay, so now we're going to derive V from this formula. How are we going to do that? So I'm going to quickly erase this. So the first thing that we're going to do is we're going to multiply the whole equation by 2. So 2 times kinetic energy is equal to m times v squared. And now we're going to divide by m. So v squared is equal to 2 times kinetic energy divided by m, and v is equal to the square root of 2 times kinetic energy over m. And when you calculate that, you are going to get v is the square root of 98.01. V is 9.9 meters per second. So now we need to find the coefficient of kinetic friction. We're going to do this by using the formula for kinetic frictional force, which is equal to normal force times the coefficient of kinetic friction. So now we need to find the normal force and the kinetic frictional force. So how are we going to do that? To find our normal force, that's easy because we know that normal force is equal to weight, which is equal to m times g. And when you calculate that, you will get 88.29 newtons. Now to calculate our kinetic frictional force, you're going to do that by first finding the work done by friction using the formula delta kinetic energy. So after you find the work done by friction, you're going to find the force of friction using the formula. Done by friction is equal to delta kinetic energy, which is equal to 1/2 m times v squared minus 1/2 m times v0 squared. So we know that the box stops at the end because final velocity is 0. So the work done by friction is going to be minus 1 over 2 m times v0 squared. And when you calculate it, you're going to get minus 441.04 joules.